Question 15 is a circle theorem question. T and R are 2 points in the centre of a circle. That's those 2 points. PT and PR are the tangents to the circle from P. Angle TPO is 20 degrees. Work out the size of angle TOR. So that's this whole angle here. You must give reasons for each stage of your working out. Now, first of all, they've mentioned tangents. And what you should think tangents is, are there any radius around? So here you go, here's a radius, and here's a radius, because it goes from the centre to the edge. Now, whenever a radius meets a tangent, it's a 90-degree angle. And that's a rule. So the first thing I'm going to write here is about those two angles. So this is angle OTP, and it's equal to ORP, which is equal to 90. And the reason is that tangent meets radius at 90 degrees. So I know those are 90. Now, in order to find these angles, I know this has been cut in half here. I've got two ways of doing it. I can either go the way of saying, well, if that's been cut in half, then that's 20, take away from 360. Or I can count this as a triangle, whereby I've got one angle that's 90, one angle that's 20, and then my missing angle. So if I just find that for now, which is angle TOP, so I'll find angle TOP, which is 180 degrees because it's a triangle. Take away that 90. Take away that 20. And 180, take away 90, take away 20 equals 70 degrees. So I know this here is 70 degrees. And because it's cut halfway, I need to do 2 times that, which is 140 degrees, because that's 70 and that's 70. 70 and 70 are 140 degrees. So 140 degrees, and they've called it angle TOR in the question. And that's the final answer. So in order to get marks for this, oh, sorry, I haven't put my reason. I knew that this was 180, take away 90, take away 20, because angles in a triangle sum to 180 degrees. Sum means add up. So my marks, I get 1 mark for having the angle of 90 degrees. And I get 1 mark for this. And then I get a final mark for having the answer. So there's my 3 marks. You then get a final communication mark for having your valid reasons. So there's your communication mark. 1 mark for the tangent rule, 1 mark for taking it away to find a missing angle, 1 mark for the final answer, and then a communication mark for having your reasons. Question 16 is a conversion question involving miles and kilometres. So whenever you see a question that mentions miles and kilometres, it's always worth writing down what the conversion point is. And that's 8 kilometres is equal to 5 miles. It's always worth having that written down. So Judy drives at an average speed of 80 kilometres per hour for 2 hours and 45 minutes. Work out the number of miles Judy drives. Right, well, first off, I've got to convert her speed, which was 80 kilometres, into miles per hour. So my conversion factor was 8 kilometres is 5 miles. So if I've got 80 kilometres, then hopefully you can see that that is going to be 10 times. So 80 kilometres is equal to 50 miles. So her speed in miles per hour is 50 mph. So she's doing 50 miles per hour, and she's doing that for 2 hours and 45 minutes. Now at this point, you can't go timesing that by 2.45 because that's not how time works. You can times it by the 2, yes, for the 2 hours, but then you have to consider 45 minutes. And 45 minutes is actually 3/4 of an hour. So if in doubt, you would put the 45 minutes out of the 60, which is how many minutes there are in an hour. So it's 3/4 of an hour, so it's 2.75. So let's do 50 times by 2 first. So that would give us 100 miles. And then let's do 50 times by that 0.75. To get to 3/4, first I need to find 1/4 of 50. I'll have to go through a half first. Half of 50 is 25 miles. A quarter would be 12.5 miles. So 3/4 is going to be 1/4 plus a half. It's going to be 37.5 miles. So what I need to do then is do the 100 miles that took 2 hours and the 37.5 miles that took the 3/4 of an hour, and that gives me a total of 137.5 miles. And that's my answer, 137.5. Now with regards to how the marks are allocated, you get 1 mark for showing a correct method of getting 50 miles per hour. So we used this method where we multiplied it by 10 because we knew what the conversion factor was. You then get the second mark for taking whatever speed you get in miles. So it's a follow through of a mistake. Whatever speed you got times by 2.75. That gets you your second mark. And then the third mark is your answer mark for getting the correct answer in miles. Question 17 is about parallel and perpendicular lines. It wants you to find an equation of the straight line that is perpendicular to the straight line x plus 2y equals 5 and that passes through the point 3,7. Now, we're dealing with straight lines here, and the first thing that should come to your mind when you hear of straight lines is y equals mx plus c, because we always want to try and get our formula or our equation into that form. So let's have a look over here. They've given me x plus 2y equals 5. So that's fine. I want the 2y before the equal sign because I want it to start with y. What I need to do now though is get that x over that side. So in order to do that, I want to take it away from this side and take it away from that side. So that's going to leave me with 2y is equal to 5 minus x. Now I want the x value first, so I'm just going to swap those around. As long as I know that's a positive 5 and that's a negative x, nothing's going to change if I call it 2y equals negative x plus 5. Exactly the same values, I've just put them in a different order. Now I've got it in that form, I need the y on its own, so I'm going to divide the 2 away on both sides, leaving me with y equals negative x divided by 2, which is negative a half of x, and 5 divided by 2, which is positive 2.5. So there you go. I have my equation in the form of y equals mx plus c. Now, I'm not particularly interested in the plus c part for the time being. I need to find out what c is equal to when they are the values of x and y. What I am interested in is my gradient here. So the gradient of the equation of my line, when it's in the form of y equals mx plus c, the gradient of the perpendicular is going to be usually negative 1 over, and then whatever the existing gradient is. In this case, it's a negative a half. So things get quite tricky here. You can think of it as 1 over, or you can think of it as being the reciprocal. Now, 1 over is the reciprocal. So in order to find the reciprocal of a fraction, you can also just flip it. So 1 divided by a half is actually going to be the same thing as 2 over 1. And we've got a negative and a negative there. So because you're dividing, a negative 1 divided by negative a half means it becomes a positive. So it's a positive 2 over 1, which ends up as 2, because 2 divided by 1 is 2, and it's positive. So this is my new gradient. That's the gradient of my perpendicular line. So here, I know the equation of my line is going to be the y value equals 2x plus c. Now I need to find what c is. So I know that they want this where y is 7, so I'm going to sub that in, and x is 3, so 7 equals 2 times by 3 plus c. So 7 equals 6 plus c. I want to get the c on its own, so I take 6 from both sides. 7 takes 6 is 1. 1 equals c. So there you go, you've got your value for what c is. So now we know that the gradient we found down here was going to be 2. And I know that c, which is the y-intercept, is going to be 1. I can write the equation of my line as y equals the gradient of x plus 1. And that's that finished. Now, with regards to how the marks are distributed, you get 1 mark for identifying the fact that the original gradient is negative a half. Okay, so if you've managed to get y equals negative a half, that's 1 mark. So the second mark is for correctly finding the gradient of the perpendicular line, which is 2. So that's down there. That's your second mark, is the gradient of the perpendicular line. And for the third mark, you need to substitute in when you've got it in the form of y equals 2x plus c, and subbing in. That's your third mark. Then your final mark is for getting the actual answer correct. So 1 mark for identifying the gradient is significant. Second mark for finding the new gradient. Third mark for substituting in your values for x and y that they've given you. And then your final mark is for getting the equation correct. Question 18 is simplifying an algebraic fraction. And the process is always the same on these. They want you to factorize the top, factorize the bottom, cancel out the factors that are the same, and then whatever you're left with. So first thing I need to do is factorize this 2x squared minus 9x minus 5. It's a 3-part in the form of something x squared plus or minus something x plus or minus a number on its own. So it's going to go into double brackets. It's going to take too long for me to explain how to factorize into double brackets here, so I'm going to quickly fly through it. The fact that it starts with 2x squared means that one of your brackets is going to start with 2x and the other is going to start with x. Now, with regards to what happens in these two numbers, they need to multiply together to get you 5. There's only one way of multiplying two numbers together to get you 5, and that's 1 times by 5. And because it's a negative 5, I know that the signs are going to be different. So 1's going to be a positive, 1's going to be a negative. By the time you run through all the different combinations and you realise that whatever number goes there is going to get doubled before it can make that negative 9, you will find that this one is going to be positive 1, and that's going to be negative 5. So that's going to be all over this factorised. Now, you might be tricked into thinking this is going to be the difference of squares, but it's not. This is a cube here, okay? So this is a cube number, and 2 isn't a square number anyway. This is going to actually go into a single bracket, so we need to remove the common factors to both terms. So I can see with regards to the numbers, 4 and 2, 2 is the highest number that goes into those numbers. Do any letters go in? Yes, they do. X goes in. How many times? Well, there's x cubed there, so there's a power of 3, and there's a power of 2 here. So that means 2 is the most it can go into both. So 2x squared is going to be on the outside. Then I put my bracket in. 2 times 2 would give me the 4. X squared times x would give me that x cubed. Plus 2 times, no need for a number because we've already got 2. X squared times nothing, okay, so I don't need to do anything there, so I can have that as 1 because I just want that to be as it is. So there you go, it's factorised, and as if by coincidence, that is exactly the same as that, so I can cancel them out, leaving me with x minus 5 over 2x squared. And that question's complete. It's a 3-marker, and with regards to marks, you get 1 mark for factorising this correctly. You get a second mark for factorising the bottom correctly, and then you get the third mark for getting the answer correct. Now, if in doubt with this, because that is a tricky one to factorise, just make it so that you end up with the same bracket on the top and the bottom, even if it means that the factorising doesn't quite work out. Because once you've done that, you can show your method and you might pick up some method marks in the actual exam.